Good afternoon, everybody. Firstly, thank you to MEP for asking Leask Marine to present here today. It's an ideal opportunity for those who might not know who we are to find out what we're about and how we can help you moving forward. My name's Olly Bethwaite. I'm Operations Manager for Leask Marine and have worked with the company over the past 8 years, working with marine renewable devices located up in EMEC in Orkney. So, Leask Marine, lessons learned from 10 years O&M at EMEC. I've split the presentation into 3 headings: Leask Marine background, who we are and what we're about, our experience, and some of the lessons that we've experienced and learned from working with the developers. Leask Marine background: we are a marine contractor that specialises in the installation, operations and maintenance, decommissioning of wave and tidal renewable devices. We're based in Kirkwall and now have a Welsh office located in Swansea. Leask Marine started marine contracts and marine construction projects in 1985. We have a wide range of experience across many types of marine projects and can offer many services as developers require. We currently own several multi-purpose vessels and employ over 50 personnel. We have a total of 5 commercial diving teams and a dedicated engineering fabrication department for small and medium-sized projects. We have over 12 years' experience working in marine renewables, extensive experience in all phases of the project lifecycle, several multi-purpose vessels, a large portfolio of customers, and worked and supported with over 95% of developers utilising EMEC up in Orkney. Following on from that is just a quick project timeline that shows just how many devices we have worked on over the past 5 years. This project timeline shows a total of 16 developers, which we have worked very closely with over the past years. So, lessons learned. I've chosen just a few problems we have experienced with the hope that as designers and developers, you would benefit in the future moving forward. With all the past investment, we don't want the same mistakes made again, and the time is now that we need success in this industry. So, slide 1, dissimilar metals. This is constantly coming up with developers and has caused major failures and issues with devices. This photo shows a pressure sensor block made out of stainless steel, and a washer of a different grade steel was fitted, and in a matter of weeks had corroded away. It had also reacted with the stainless steel, requiring the whole assembly needing replacement. So the lessons learned moving forward with this is to try and keep dissimilar metals to a minimum, which will reduce corrosion issues with the interaction of different materials. Suppliers do need to be checked, as we have found that some parts supplied do not meet the correct specifications, and be aware of the different grades of materials, to which some parts can act as an anode and cause other main parts to fail. And with a lot of these devices where you have electrical current present, be aware that this can accelerate corrosion and extra cathodic protection may be required for the device. Moving on to cathodic protection, the lower 3 photos show continuity issues that we have experienced. The lower left photo, which is the GRP pipework with stainless steel flange assemblies, as you can see, between each of the flange assemblies, there's no continuity or protection between the flanges, hence acceleration of corrosion. The lower center photo shows the neck of accumulator cylinder. The problem was found that with a painted cylinder had been mounted on rubber mounts, so no continuity was established. The neck and the valve had acted as an anode, resulting in the pressure failure on the cylinder. And the lower right photo shows stainless steel fittings mounted on flexible hoses. These quick release fittings are classed as stainless steel, but we have found that the ball bearings and washers and other internal components in these sometimes are found to be of different grades and materials, causing earlier failures. The 2 upper photos shows an anode fully depleted, which has been replaced by a diver and welded. Upon discovering that the anodes were depleted on a device, it was not considered by the developer that they would need to be replaced in such a short period of time. Divers had to be contracted to remove the existing brackets and weld on new replacements. Advice to developers is to design that the anodes can easily be exchanged if the need arises, and this will save on time and money. It is also better to overcompensate with cathodic protection, as anodes are far cheaper than parts, to which some developers have unfortunately discovered. Staying with cathodic protection, steel wires and ferrules. Nearly all developers at some point have used steel wires, whether it's for device tethering or mooring installations. If you go to an oil gas supplier today, I would expect them to supply a wire with the correct rating, yes, but usually with an aluminium ferrule. This would normally be fine, but in a prolonged, shallow environment would not be suitable. The photo shows just 4 months corrosion. The photo on the left shows how effective a small anode can be and how it can prolong the life expectancy of a wire. But the one issue is that the environments that we are tested in is a likelihood that the anode will not stay attached. So since testing and our experience, we now advise developers to use steel ferrules with anodes. If the anode is lost, the ferrule has the same properties of the wire, so all corrode equally. But if it's an aluminium ferrule, that would act as an anode for the wire and has resulted in early failure. This very issue has resulted in developers having to repurchase wires in a very short time frame and often not allocated in project budgets. Number 3 would be shock loading, fatigue duration. The picture shown on the right is showing the prolonged forces and shock loading effects. This 300-ton Kenterlink was used for joining chain lengths together. It's used widely across many industries and yes, is rated and used for joining chain, but with using this joint, it is shown it creates a weak point for failure. Items like these are not designed for some of the prolonged forces experienced on renewable sites and if possible are best not used. The picture on the left is showing how a shackle has failed due to shock loading from a device. It was decided by a developer to secure the shackle by welding the nut to the pin. This in turn tightened the nut when tension was applied and cracked the nut, resulting in failure. The reason for welding was the securing pin was constantly failing due to the movement and loading. As you can see from the photo, the pin is bent outwards. Moving forward, the problem was solved by using stainless steel bolts with night locks through the shackle pin, which is far stronger and outlasted this standard securing pin. Subsea connections. Subsea connections play an important role on all devices. The photo shows how an unexpected fault can occur. This connector was in perfect order on surface and all electrical testing complete. It was then sealed and secured with other cabling. The connector had been used for a number of weeks at different depths, and then the failure had occurred. This connector was disregarded as being a fault, as it had been checked and secured by electrical engineers. A lot of time and money was spent looking for the problem, and a lot of parts recovered and tested. This is just showing how simple a fault can be, and not all parts supplied can have obvious defects. The lessons learned from this would be to check the obvious and don't assume that all parts are supplied are fault-free. This part was fault-free until used on site and at depth. Yeah, no problem. We have found that making some connections subsea have failed due to water ingress. We have found that this has taken multiple attempts to make successful connections with the use of silicone gels to displace water from the connection pins. We would also advise, wherever possible, to make all connections on surface, as the connector will be dry and will in turn have a prolonged lifespan. Moving on to cable management, over the past years we have constantly changed out cabling on devices. The importance in designing cable routing on devices will have a significant impact on the allocated maintenance budget on a device. From our experience, whenever you have 3 spans of cable greater than 300 millimeters, over a prolonged time the cable will flex that much it will fail. Developers in the past have contracted divers to add cable trays and steel fixing points to stop these failures from occurring. Our advice moving forward is to ensure the cable management is in place and sufficient on your device. This will be a significant cost saving during testing and operating stages of your device. And one of my last slides is diver and ROV intervention. Always plan for diver or ROV intervention, as all devices that have been installed have had some form of intervention at some point in the life cycle. Plan and design certain tasks which may need to be performed. This will make a simpler and quicker task for the diver ROV to complete if the plan is already in place. This in turn will streamline the operation and keep device downtime to a minimum. And modular design. Devices at some point will need parts to be replaced and exchanged. This is usually on site as developers want the device left out operating as much as possible. Aquamarine progressed from Oyster 1 to Oyster 800 and included the concept of modular design. After working with Oyster 1, the design was every part was individually attached and needed some type of securing removed before replacement could be installed. This equated to a lot of time on site and diver time required. So moving forward, on all parts are intricate and require precision, it may be worth considering that it be made modular, easy for the diver at ROV to recover or install new parts. Modular design definitely provided an impressive cost saving for prolonged device testing, so it may be worth considering the designing moving forward. I think we should need some new batteries for this. Yeah. And my final slide, just a few list points to maybe consider moving forward. This is purely on observations from working with developers over many years. The consideration of water depth for maintenance, inspection and on-site repairs. Only use experienced contractors that understand the challenges and dangers of working in the wave and tidal environment. This will save time and money. Always have experienced client rep on board that understands the challenges and difficulties. Where possible, use engineers that have offshore experience. Always involve good experienced naval architects. Listen to any ideas or suggestions from any of the experienced team involved in operations. And number 7, of course I had to include this one, always have an experienced operations manager on board for operations. So thank you very much for listening. I hope that some of the lessons I've mentioned today will be of use to yourselves moving forward. And I'm available through the afternoon if anybody has any questions. Thank you.